test one for your subject that you have enrolled. Okay. All right. Good luck for that. Okay. So let's look the attendance for today. Um, today is 19. Okay. How many? Oh, 41. Okay. So we need wait for the rest. Okay. Uh, just want to share to you. Okay. What is it? This one. Okay. So I have developed some apps, right? Mobile app. So during this MCO, right? I'm free, right? So this app can deploy for Android and also iOS, right? Okay. Let us check the attendance for students. Okay, one student. Fine. 1, 2, 3, 4, 5, 6. Okay. You have attending 6 class. Okay, good. Okay, it's pretty cool, right? Okay, for today class, we will do some revision, all right, for our test one. For your information, your test one will be on this Saturday, 21 November 2020. And it will start at 9 a.m., right? On the morning, okay? So, and 1 hour, 15 minutes at the time, right? Okay. So far, do you have any question regarding the test one? Okay. I can see a lot of picture cat there. All right. A lot of cat there. Okay. Dr. Afdal Alif. So, how the numbers of COVID-19 right now? Okay. Aduh, sir. Don't know lah. You are doctor, right? Okay. Alright. 47. Okay, don't forget to slide in your attendance for today. Alright, so let's move on. So what we're going to do for today is just for revision. You can ask many questions that you want, and I can answer that. Hopefully, I can answer that. Okay. But remember your test one will be on this Saturday, so you have today and tomorrow. So don't sleep, right? So just study, just prepare in your place how to make some what we call it adjustment about how to copy each other, so you can try to create a group WhatsApp, right, among of your friend. Okay, and maybe you can start to stick out any notes, right, on the wall. Okay, macam itulah. Okay, alright, anything good? Can we start our class now? Boleh?
Yes, Doctor, boleh.
Okay, boleh. Alright. So, your test one will be start from international system actually. So this is what you have learned, right? A lot of system that you have learned here, but most of that you don't learn electrical system and thermal. This one is okay lah, but it doesn't matter, right? Okay, and we have learned about the spring. So the spring have one is rigid, one is free. Okay, so we want to know the force is from the spring. Okay, So remember the input, right? We assume that input is more bigger than the output, okay? And then we also have the damper, okay? Also have the rigid one, and also both is free, okay? And we also had the mass body here. And in this chapter, we also learned that when are given a system here, so we can come out with a mathematical model, all right, or we call it a differential equation. And then we start to draw the block diagram here. Okay, then we have do this a lot of time. And then we also have a rotational system, okay, like you have the shaft, okay, you have the shaft, right? It's like the spring. So shaft have what we call it. One is free, one is rigid. So this shaft, when you have the angular displacement, right? Angular displacement in terms of angle, right? Angle. So you will have some torque here, okay, all right, and then also the damper. When you have the damper here, so the torque at from the damper will be opposite. And also you have the initial body, right? When you apply the torque is equal to J alpha JD uh, uh, squared theta, okay? And we have done this one, okay? And then we have learned about gear system. It's okay, I just go through, and then after that we will do some previous tests, okay? It's not the test, all right? It's previous. Okay, then you have some gear here, all right? And then remember the gear, it will be opposite direction, right? So that the gear can move in, for example, clockwise, and the one is anti-clockwise. Okay, and we also know that when we have the angular displacement here, right? Angular displacement is like the angle here, right? Angle. And then you have the radius, right? For example, R1 and also R2, and you also have the angular displacement for the gear 2. So for the arc length, right? Arc length, that's mean this one, right? Arc length, for example, this one, arc length, right? So this one is will be equal. The gear 1 and gear 2 will be equal, okay? So some of you cannot solve others example question because of you forget about the arc length, right? This one, okay? Please remember on that. And then from the angular velocity, we also can find the from the angular displacement, we also can find the angular velocity, okay? And then when you play around with some gear, there will be some forces, right? And then some forces will produce some torque here, and then the same force we apply to another gear here, okay? So then we also have done example here, okay? So that's it for the gear. Alright, and then you can read another one, level thing, level system and liquid level system. Okay, I'm interested with some of your friend that asked me about, yep, this one that combine between spring, mass and damper, mass spring damper, right? Okay. And then you have spring here, damper and mass, okay? And then it have the pulley, right? This one we call it pulley, right? Okay. This one has been shared by LCT. Okay, good. So maybe we can share with your friend here, right? So now you have the theta here, okay? And then this pulley have the initial, right? In a moment of initial, right? This is J. Okay, so the inputs now, if I'm not mistaken, is what is it? The input, LCT. What is it? The input, theta or wait ah. Okay, let me get back. What is the input? The input, yep. The input is F. Okay, the output is theta. Okay, so let's try to solve this one. Okay. Okay. Alright. Everybody, are you ready? Do you have any question about this one? Not yet? Okay. So let me show you how to do that. Right. Okay. Now you got a damper here, C, and then you have the mass here, M, and the mass is free. Then this is the X. Then you have the F here, and you also have the spring, and this one you have the pulley. Okay, up, and then you have the theta, and you have K, and you have K here. So this one is like you have pulley, right? This one. Okay, and then the pulley have the initial body. Yep. Iman Zaid, please mute your mic. Yep. Then this is theta. Okay. All right. Okay. Now, what do you have here is input pulley. Wait for a minute. Okay. Based on the question, you have the input F, and also the output is theta. Okay. Yeah. All right. So now you have two body here, mass and also the pulley, right? This is a pulley. So mass, you have three connection there. Okay. All right. Let's draw the mass first. Free body diagram for the mass. This one the M, and this one, okay, we don't know yet, and we have this one. Okay. So input F, right? F is your input. That means it will start from mass here. Okay. Alright. So when you push it right on the right, so what happened to your spring, right? Your spring will kick it back, right? Okay, that means this spring will be Fs here, right? And the another one will be like this one. Okay, so and also with the what happened to the damper when you pull it at the right, so that means your damper will try to fight back. So you got it FD here, Fs F, Fs FD. Okay, then you got it as Sx here. Okay, so far this one clear. Do you have any question? Are you still remember, right? Masih lagi ingat kan? Okay, right. So I don't have any question, so I proceed. So now you have the summation of force equal to MA. So because the input going to that right, the right, so going to the right will be positive. So now what we have is F minus Fs minus Fd is equal to Md squared X. Okay, now you got it, the first equation. Okay, is it clear, this one? Any question? Okay, good. Alright, then you will look
Yes,
at the spring. Okay, at the spring. Okay, this is spring. And then after that, we will look at what we call it pulley. Here. Okay, this is R. Alright, that means this one is theta. Okay, so now Fs is here, so you will have one more Fs going to pulley, right? This one is Fs, right? Fs here, Fs here, Fs here, and Fs here. Okay. So when this force, right, try to push the pulley, that means it will generate some torque, right? Is it? So we call it TS. Okay, clear? Clear, right? It is like when we mention about torque, that means it should be force, it should be 90 degree, right? For this one is Fs. Okay, so what you can get from the torque? Okay, Ts, I put it Ts, so that means R Fs here. Okay, so this one is number 2. Okay, right. So this pulley have the what we call it, the moment of inertia here, right? So that means you will have some torque going down here, Ts. Okay, so now you can get it as summation of torque equal to J alpha, because you only have Ts here. So Ts equal to J d squared theta. This one, question number 3. Okay, this pulley, is it clear? Do you have any question? Ada apa-apa soalan tak this pulley? Clear? Okay, good. Right. So now we have 1, 2, 3, 4. And then we have another thing. If Fs equal to Ff for spring is K here, right? So look at here. K here, this is X. So that means this is X. Right. So what is this? What is this? Right? Is it theta? Is it theta? Is it this one correct? Betul tak that one? Is it theta? R theta. Yes. You are good, Lalita. Okay. So this one is the displacement, right? The length. So this one should be the length. So the theta is not angle. So the length should be arc, right? Arc length here. Okay. So that means you will have the theta here. So this one should be r theta. R you time with theta here, you will got it this arc, right? This arc length here. Okay. Can you get it? Okay. And right. Okay. So you will have Fs, that means K, input minus output, that means X minus R theta. Then you will got it is 1, 2, 3, is one number 4. Do you have any question about this one? No? Okay, so I should proceed. FD, that means X here. So one is rigid, one is free. So it means you have a CD and X. Okay, so this one, question number 4. Alright. Okay, so you got it 1, 2, 3, 4, and this one 5. Sorry, 5. Okay. Alright, so this one is Fs. Alright, clear? Is it clear? Okay,
Yes,
good. So now you start to draw the free body, the block, the diagram, right? So you have here, let me solve number 1 first. So you have the F, and also you have FD here. I figured FD, you have Fs here. Now you got it plus, minus, minus here. Then the output will be F plus minus. So if you time by, okay, 1 over md squared here, and then you will got it X. Okay, done. So you will have solved number 1, done. Then let's go for equation number 4. So you just minus with the r theta here, plus minus, then you time with k here, then you will got it is fs here. Okay, all right, we are done this one. So now we done this one. Okay, now which one that we going to solve? Solve number 2. Okay, try number 2. So fs you time with here is r, now you got it is ds here. Okay, so number 2 we are done. Then ds you time with 1 over jd squared. Okay, then you will got it is theta, because we want to our input is f and then our output is theta. Okay, right, then we have solved this one, done. The another one is cdx here, so this one cd. Okay, and then what else? fs you can take here from here, fs. Okay, done. Okay, and then theta here we can take it time with r, and we got it is r theta. All right, so that's it. Okay, any question? Any question? Ada apa-apa soalan ke? Tak ada.
No, sir.
No, yes, Lalita, good. All right. Okay, so is it clear? Clear. Okay. So what is it? Okay, sometime, right, the block diagram, when you try to do the block diagram, that means sometimes you cannot solve, right? So try to combine the equation, right, between the mass and also the moment of inertia. For example, this one, the equation number 1, try to substitute it to equation number 3 here. Okay, all right. Okay, so let's me with this one. Okay. Alright, let's think a little bit. Let me modify this one. Right, let's say I put a spring here, right? Okay, and this one is my final one, so I put it is y. Okay, so let's say our input here is y and output here is x. Okay, all right, so this one is k1 and this one is k2. Okay, so what happened here? Right, what happened here? So now what do you have? Okay, so let's think a little bit about this one. Okay, alright, so we draw the free body diagram for the mass first. So mass have 1 and also 2, then this one will be going to this way, right? Because the input you pull in, right? You pull, right? So that's mean the forces at this one. Okay, sorry. Okay, sorry about it. Sorry. Okay. So you need to look at the input first, right? So you push the spring at this one, right? That's mean at this point the spring also will be pushed at the right. So it try to back, right? Okay, fight back. Okay, then you will get the direction like this one. So this one will be fs1. Okay, clear tak? Clear? How do I got this direction?
Clear, doctor, clear.
Okay, good. So that's mean when you pull this mass at the right, so what happen? Your damper, it will go to the left, right? Right? Pull it, so this one go to the left. Okay, so this one solved. Then this one, it is direction. Now we look at the input going to the right. First, input for the mass going to the right. So we said that going to the right is positive. So fs1 minus fd equal to md squared x. Okay, done. We already got this one. Okay, so now let's move. Okay, we have the spring here. Okay, this one is K1. K1 is X here. And this one is R theta. Okay. Alright. Then we look at the pulley. So you have the pulley here. So I draw, yeah. Okay. Now you have the force going to this direction, right? This is the Fs1. This one, right? Fs1. Okay, done. Okay, and you have the R here. And then at this point, right? When I push it, right? I put it this point, right? At Y, I put it. What happened to the spring? It will try to fight back, and this point will try to go to this direction. Alright, so this one is Fs2. Now you will have another force going to that direction if Fs2. Okay, right? So this one is the theta. Okay, so you got the two forces here. So how many torque that you will got it here? How many torque? That means 2, right? Okay, one it will go to which direction? Okay, so R time with the F2, right? Going down, that means you will have some torque, right? You will have some torque going down here. Okay, right? And then some other torque going to this way, so you will have another torque going down here. So this one I put it is torque for TS2, and this one is torque for TS1. Okay, right? Boleh? Boleh? Okay, good. Right. So it is like you have the J here, right? This you have J. It is like the torque TS2, and another one is going up. Okay, this one is TS1. Okay, so uh, let's solve the moment of inertia first. So that's mean what happened to my text? Okay. So that's mean you have the input going down, right? So the input going down, so going down is positive. So you have the TS2 minus with TS1 equal to it's not MD because the J D squared theta. Okay, theta here. Alright, done. We are done there. So this is the equation 1, equation 2, and then you can have the equation TS2 here is equal to R Alright, so you time with the FS2. Okay, this is the question number 3. Then you also can have the TS1 here. Okay. TS1 here is equal to R times FS1. Okay, so this is question number 4. Right. Okay. So now, the important thing is the equation for the spring and also the spring. Okay. So what do we have? First spring, we have this one, K1. So Fs1 is equal to K1. The input, okay. The input should be, what is it? The K1, the input, when you put it there, what is it? It should be R theta minus X. Is it correct? R theta will be the input, right? Because you pull it from Y, right? R theta it will be input. You pull it from Y. So R theta here, okay, right? This one, R theta here, okay, this one, right? So you got it, the equation number 5. Okay, done. Then you can get it FD here. CDX equation number 6. All right. And then what's else? Yep, you have another spring here. So the spring is Y here, and also this one is theta also. Okay. So you have the K2 here. So be careful with this one, right? R theta. Remember about it. And then you will have the Fs2 is equal to what is it? K2, right? Which one the input? Okay, Y is minus with R theta. Then you got it, the equation number 7. All right, so that's it. Okay, can you get it? That's it. Yeah. Okay. So you can draw the block diagram here, right? So if you cannot, sometimes when you draw the block diagram from the input, right, and then you stuck at the what you call at the center one, right? Right. So sometimes you need to combine between the mass one and also the initial one, right? Uh, the number 2, right? And maybe sometimes you can insert it back this one, we insert to this one, okay, and so on lah. Okay. All right. Do you have any question about this one, the pulley? No? Is it clear? Okay. Sorry about
Clear,
the.
sir, clear.
I don't know what to do. Yeah, close this one. Later on, I will close this one. Okay. Right. Is it clear? So this will be what we call it your solution for this when you have the mass and also you have the pulley. Okay, so clear, that's it. Right, thank you for your friend LCT. You share with this problem. Okay, all right, and also you can also look at another past year question, right? Let's look past year question like, yep, okay. This one, right? Past year question. You can try this one, right? So I'm also got it, this question from your seniors, right? Right. A student asked me how to do this. Okay. All right. Good. So for system, So please read the directional rotation gear, right, and other thing. Okay, and then the test one also will be cover about the block diagram. Okay, block diagram manipulation. So please remember about this type of manipulation method. Okay, I think you don't need to remember because you can look straight away, right? During the test one, the first thing is open my lectures note. Okay, is it? Betul
Betul.
Betul. Aduh, haha, betul betul. Okay, open first. Right. Okay, so bear in your mind, please look first. Okay, look the closed loop system here. So try to solve the closed loop system here, and then another one try to solve the closed loop system here. And remember, uh, there is no method that you can transfer junction to before the summation, okay, before the comparator. There is no method. You only can transfer junction over the gain, right? Over the gain, this one. Also, you can transfer the summation, right, or comparator over the gain, right? So there is no method you can transfer before the summation or after junction. Okay, so we have done this one, right? This one, so need transfer. So first, you need to look at the closed loop system. Which one the closed loop? Yeah, you don't have any closed loop. And then second, look at the junction. Okay, oh, junction that you need to move to here. Okay, then when you move to here, you can move where? What is it? Uh, I don't remember this one. Okay. Okay, so try to look again for the block diagram manipulation. Okay, then we go through for lecture 2. Ayam. Oh, ayam nikah. Did. Is the signal flow graph, signal flow diagram include in test 1? I can't answer that. Okay. Be clever about it. Be smart about it. Okay. All right. Now we move to time response. Okay. So what you have learned about this time response, that means we will learn about the time response, right, and also the Laplace in order to solve our differential equation. So for example, you got a differential equation like this one, then you can use the Laplace, blah blah blah, blah blah blah. Okay, blah blah blah. Then you will use this what we call it, the Laplace table. So during that test one, please open this Laplace table. Maybe you can stick into your wall, but okay. And then we have using the Laplace, right? And then you can get it time domain, right? So when you use the Laplace, you will got it in Laplace domain. And then when you use inverse Laplace, you can get back to the time domain. Okay, and then you will also try to solve by using the partial fraction. So remember the concept of partial fraction. This the example that show to you. Okay, if let's say you have the equation, so that means you can divide it into a few fraction, all right? And then you will multiply with the denominator. Okay, all right. So this one done. And then in chapter 3.2, we have go to the first order system, right? Okay, the class is doesn't matter. All right, in the first order system. All right, so first order system. Okay, let me close it. What rotation D close? Okay. All right. So the first order system, the most important thing about the first order system, the concept is there is two uh, two block diagram, right? I say two block diagram. Okay, that you need to remember. So this one in Laplace domain, okay, let's say this one is SIS and the output is S not S, okay. So you will have gain here K or controller, and then you will have a process here 1/1 plus ts, okay. So where is your K in the controller? Ts is time constant, T is time constant, okay. This is in Laplace domain. And then you will have in time domain, okay. So now you have the SIT, the small letter SIT. This one also K, and this one will be 1 minus T over time constant here. And this one will be output as not T. Okay. So just remember these two things, and then don't forget to remember about the behavior, right, of the Laplace or of the first order system. Okay, so this one will be in terms of time domain. It's not T, right? This one is T. Okay, and then you will have one parameter that we call it is time constant. Okay, right. So the output for this one, right, for this one is, the final one is 1. Okay, it's 1. Okay, right. And then for the time constant, that's mean 0.63. That means 63% of the output. All right. So 66% time with output, that means your final output is 1. Okay. All right. So what happen if you have the K, right? K now is equal to, for example, I put it here is K equal to 2. So look at the graph. Oh, I just draw a little bit. Okay. This is T, and this one is S not T. Okay. And this one is the 1. This one you got the time constant here, and this one is 0.63. Okay, so when K equal to 2, that's mean how to draw the graph actually. So it will have the same graph. Okay, it will have the same graph here. Okay, right. Okay, the time constant will be at the same. Remember, the time constant is at time. Okay, the time constant will be the same. So what is this value? What is this value? The final one. What is it? If K equal to 2. Yep, LCT. Good. So is equal to 2. Because 2 here, K, you time with this point. 2 times 1 is 2. Okay. And what is this value? Is 2 times with 0.63, right? 2 times with 0.63. So take just take it my calculator there. Okay. 2 times with 0.63. So you got it is 1.26 here. Okay. I'm right, correct? Time constant will be less than. Alright. So how to derive this equation? Right, based on this one, XO divided with SI is K1 plus TS. So for example, your K now is 2. So 1 plus ds. Okay, so t you can get it, right? It depending on the question. Okay, now first order, is it clear? Okay. Okay. No. Do you have any question about this? No. Okay. Alright. So let's do uh, uh, example about this one. Q2. Will question us? We question us what? Doctor, need sketch graph? Yes, you need to sketch graph. Yes, it's a very simple to sketch the graph. Okay, let's look this one. An investigation of time response was carried out on a water level system using step input. Okay, it is found that with the input flow rate Qi equal to 20 and the head of the system H reach its steady state at 40 meter and it takes 2 seconds to reach up 25.28. Obtain the transfer function and the time response. Okay, and then you sketch the time response here. Alright, so let's look how to do that. Okay, right. Now you have here, okay. It's the same thing with the last example on the first order. So, we found that. Okay. So now you have the input Qi. Okay. Qi in terms of t, you got it is 20. Alright. And then H, you have the H in terms of t, you got it is 40 meter. Alright. So let's draw the graph for the H. So H, we can say that the first order. Okay. So the maximum one is will be 40. Alright. And then it take about 2 seconds, right? 2 seconds in order to achieve 25.28. Alright. So this is the information that are given from the question. Right. So now it want you to obtain the transfer function. That means you will got it is Fs over with GIS equal to K1 plus Ts here. Okay. So this is the transfer function, right? So we want to find the K and also we want to find the T. All right. Okay. That's it. All right. And the time domain. Yep. Time domain you can get it as T equal to K time with 1 minus e power of T divided with T. Yep. Okay. So this is our objective for this question. Now let's check whether these 2 seconds is it the time constant or not. So the concept is time constant is 63% you time with final output 40. Okay. Now what do you got it is 0.63 you time with 40. Yup. You got it is 25.2. Kira aci lah. So that means your time constant will be equal to 2. Okay. Alright. Boleh? Good. Good, Okay, do you have any question? Alright. Is it clear this one? Clear? Yep. Okay. Now you want to have this one. Okay, transfer function. QIS equal to K1 plus 2S. Okay, good. And we change it to the HT. So QIT, what do you got it? You got it K, you time with 1 E minus T over 2. Okay, that's why these two equation will be depending to each other. Okay, we only got the what we call it, the time domain, right? The information about time domain, right? Okay, T. Okay, so let's move here. Let's say is T going to infinity. Now you got it, HT going to infinity here, and then QIT going to infinity here. So what happened to K? 1 minus E minus infinity. Okay. Right. So this one K, right? Because this one is 0, 1 over E infinity. Okay. Equal to, oh, sorry, it's not 0. Yep, 0, 0. Yep, correct, 0. Okay. This one, 1 over log of infinity here. Okay. So H for T going infinity, you can see that this graph is 40. Okay. At the infinity one, it will go to 40. So now you got it is 40 divided with 20. Okay. Because the question say that it is found that with the input flow rate Qi equal to 20, the head of system reach its steady state at 40 meter. So 20, it will produce a 40. So now you got it is K equal to 2. Okay, so the transfer function for SS over QIS equal to 2 divided with 1 plus 2S. Okay, I'm right. T is 2S. Yep. Okay, that's it. Okay. Right? Clear? Is it clear, this one? Wow. Okay. Good. All right. So your friend asks need to cache. Yep. Correct. Need to cache out. So how to cache? Okay. So we look at this one first. You have the equation Fs over Qis 2 over 1 plus 2s here, right? Okay. All right. So when you want to draw, oh, what happened? Okay. When you want to draw this kind of graph, right? In terms of the okay, never mind. So we can have okay. So let me do like this. 1 plus 1 plus 2s. Okay. Or in terms of time domain, you can get it 1, 2, you can time with E T over 2. Okay. So this one is the time domain here. Okay. So you want to draw the graph here, right? So how to draw it? Let me do like this one. Okay. Now you got it is HT. Alright. So it will be the first order. Okay, this one. And then the time constant, it will be 2, right? Because it's t equal to 2. Okay. And then this is the final one is 1. Right? Okay. So we draw this one first. right? And then you have 2. K is 2 now. So that's mean the final one is 2. Let me draw. Okay. So now you got is the curve touching the dotted line, almost touching, but never mind, you can draw touch it or not, it doesn't matter lah, but it's almost touching lah, almost touching. Okay, so what did we got it here is 2 0.63, so 1, right, 2 times 1 here, so you got it 2 here, right? So this one, the time constant it will same, so this one is we 1.26 here. Okay, now you got it is QI is 20. QI is 20, right? So what happened here? So it is like you have the what we call it the HT. It is like you have 20 here, right? You time with here. Okay, do you get it? So this one is the graph, the second graph, this one, right? Right? Okay, and then you have another gain is 20. That's mean 20 you just time with 2. So the final one that you got it is here is, what is it? 4T. Okay. Do you understand about this? Yep. Okay. So this one is the first graph. First graph, the basic graph. It will end at 1, right? Okay, the basic graph. Okay. Alright. And then you have 2. Is K is 2, right? So the second graph will be this one. This is the graph number 2. Because K2 is times by 1 and 2 also times with 0.63, this one. Alright. Then you will got it, another input is 20. So 20 you time with 2. So you will got it 40. So this is your second, your third graph. Alright. The time constant will be remain same except the value for this one. So that's mean 20 you time with 1.26. 20 you time with 1.26. So this one you got it is 25.2. So it will give you the same graph with this one. Okay. Do you got it? Clear? Faham eh? Alright. Okay, and HT here of course will be 40 minus 40 over 2. Okay. Clear? The concept, is it clear? Draw this one first. Okay, and draw the second one. And draw the third one. Okay, this one, the third one. Okay. Alright. What is it, Jen Quet? Okay. Same thing with this one. Like the last example, we have this one top. And you just need to draw the first graph for 1 over 1 plus 0.4s. Okay, this one. And then you just multiply it is 3.3 here times by 6, right? 3.3 times by 6, you can get it 20, right? Okay, the final one. Okay, so this one is 6 you time with 3.33, that's mean 20. Okay, 3.33. You should have the second graph actually, right? So this will define your third graph here. Okay, the third graph here will be the input is 6, right? You time with the k, this one, then you got it is 20. Okay, right. So this means that are included. Okay, clear, done. So let's go through. Yep, we coming back ahead here. Okay, for okay, so let's look this one. Question 2. If a step input equal to 2 is given to control system governed by the following differential equation and initial condition all 0 and all initial condition of 0, obtain the time response of the system. So now you have the d squared yt divided with dt squared. Ya, susah lah. Tulis macam ni lah. E squared yt plus with 3d plus with 3d pula 3d yt plus 2 yt equal to 3 dut. Okay, plus 2 ut. Alright, so be careful with this one. You need to double check. Of course, you can double check with your friend, right? Right? Or you don't need to double check. You just copy. Okay, alright. Okay, so now when you do the Laplace, so that means try to Laplace one by one, right? Try to Laplace one by one. D squared yt. Okay, so what is this one? You need to look at the table for Laplace example first order. Yep. Okay, so this one will be s squared ys minus with s y0 minus with y0. Okay, right. So okay, sometimes this one, right, we write with this one, right? There are one dot here. Okay, so sometimes we write like this one. Okay, so because all the condition is equal to 0, so that means 0 here. So now you got it is s2 s. Okay, done. And then you Laplace for 3d yt. Now you got it as ys. I'm also forgot about this one. Yep, you and then minus with y0. Okay, now all is 0 here. So this one have 3 times with this one, so you got it 3s, so ys here. Okay, and then the rest is 2 yt. Now you got it is here is 2 ys here. Okay, and then you Laplace for 3 dut. Okay, now you got it is 3 times s us minus with u0 here. So this is 3 as us here. Okay, then 2 ut here. Now you can get it 2 us here. Alright, and then you start to combine back. Okay, so you got it as squared ys plus with 3sys here plus with 2ys here equal to 3sus here plus with 2us here. Okay, now this one you can take it out. Okay, plus 2 equal to 3s us is show yet ut equal to 2. So ut equal to 2 in term of Laplace us equal to 2 over s. Alright. Now you have a 2 over s here plus 2 over s here. Then this one is ys. It will be take long. Okay. Sum you have 6 plus 4 over s. Okay. Now you have the ys here. 6s plus 4s squared plus 3s plus 2. Okay. Alright. So the solution will be quite long, but it's okay. You have time to copy from your friends. Okay. And then you start doing the what we call it. Oh, no question, no solution there. Okay. So from this one, okay. Alright. So you got it is ys 6s plus 4s. This one you can factorize it, alright, s plus 2. Now you have s plus 1, s plus 2. This one you need to do the partial fraction, a1 s plus a2 s plus 1, then plus with a3 s plus 2. Okay, then you start to find the a1 equal to 6s plus 4 s plus 1 s plus 2 multiply with s, so that means s equal to 0 here. Then you can cancel out this one. All is 0, 0, 0, 0. That means 4 divided with 2 equal to 2. Alright, then you find the A2, you find back the A3. What is it? What is it? And then you will got it is ys. What is it? 2 over s plus something. And then you will use the inverse Laplace to get it the equation here. Okay. All right. I just leave it to you. Okay. So I think that's it for our revision class for today. All right. I hope that you can follow all my steps there. Okay. So if you have any question, you can ask me. Okay. And I wish you good luck for your test one on this Saturday. Okay. Do you have any question that you are you going to ask? No? Doctor, is it the test hard? No, it's not hard. You will see that. Wow. Is there any test one sample? I think you can get it from the e-learning, I think. All right. Or you can get it from your friends. All right. Okay. I will try to upload it in the e-learning. Okay. You can WhatsApp me directly. Okay. Anything else? Dennis, all right. Happy Deepavali. Awak lah yang main mercun itu Okay. Good.
Teruk. Yes.
Alright, Lalita. Okay, good. So I think that's it for today. So good luck for your test one. Okay. Any update I will send through to WhatsApp group. Okay. So I think that's it for today. Alright. And I will see you again on this Saturday and also on next week on Thursday. Okay. Bye bye. Assalamualaikum.
Thank
And
you,
good
sir.
luck. Okay.
Thank you, sir. Bye bye.
Bye
Thank
bye.
you.
Bye.